A metal oxide semiconductor field effect transistor, MOSFET, is made of p or n-type doped silicon. In this example, the substrate is composed of p-type doped silicon. On this substrate, there are electrons, shown here in white, as well as holes, known as electron holes, shown here in green. Through ion implantation, two n-type regions are formed. The term n-type signifies the fact that adjacent to the normal silicon electrons, there are additional electrons which are free to move around, shown here in red. An insulating layer is needed. This is typically produced with silicon dioxide. Above this, a layer of aluminum is applied via vapor deposition. Finally, a second layer composed of silicon dioxide is applied, in which contact holes are created through etching. The transistor is now ready. Taken together, there is a p-type substrate with two strongly n-type regions, as well as electrical contacts which provide the transistor with the necessary current and voltage potential, known as the source, gate, drain and bulk terminals. Source and bulk are often connected to each other, so they share the same source of current. The objective is to control the flow of current between source and drain. This is accomplished with the gate. If there is no voltage potential at the gate, there will be no current because no carriers of current are available between the two n-type regions, shown here in red. However, should there be a positive voltage potential on the gate, a positive electrical field builds up, which attracts electrons in the p-type layer and repels holes. These electrons form an n-channel that can carry electrons from source to drain. It should be noted that the current between source and drain can be increased through raising the voltage potential, which leads to a stronger electrical field and thereby a larger n-channel. Since no current is able to flow between source and drain when there is no potential on the gate, this type of transistor is called enhancement mode MOSFET. MOSFETs are increasingly used in integrated circuits, for example those used for microprocessors. Since only electrons or only electron holes alone take part in carrying current, this type of transistor is considered to be a type of unipolar transistor.